Hello everybody and welcome to the second of the 5 webinars we have lined up for you this September. Today I'm joined by Simon Stewart and he is going to be talking to you about the brand new Selenium 3.0. If you have any questions for Simon, please feel free to type them into the questions field there on your control panel, and at the very end of the webinar we will come back to all your questions one by one. So now let me hand you over to today's presenter, Simon Stewart. Hello, Simon.
Hi there, how are you?
Great, great.
Okay, I will just get the presentation up. Can you see?
Yes.
Perfect. All right, then I'll get going. Thank you very much for that introduction. I'm Simon Stewart. If you have never heard of me, which is entirely possible, I'm the lead of the Selenium project. I created WebDriver almost 10 years ago in January, and I'm the co-editor of the W3C WebDriver specification, which is a standard effort. I'm also available on Twitter as SHS96C, and today I'm going to be talking to you about using Selenium 3. So, before we can go forward, we should go backwards. And we'll go all the way back to Selenium 1.0. That release was years ago now, a long time ago, and Jason Huggins was the project lead. Now, for those of you not familiar with it, Selenium back in the day started life as a sort of table-based runner, and that table-based runner was based off the work of Ward Cunningham and his work on FIT, the functional integration testing. You may have seen sort of similar approaches before, but effectively the Selenium tests were an HTML table with a left-hand column describing a particular action to take, such as open a URL, type in a field, click on a button, and the remaining 2 columns either being selectors or arguments to pass to the command to execute. So there are 3 columns in the table. If you use Selenium IDE and you export an HTML test suite or an HTML test, then you'll be very familiar with that format, because this format is the one that still exists. Selenium itself was written by Jason Huggins. The initial version was written by Jason Huggins when he was working at a company called ThoughtWorks, and it was used for the time and expenses system. The time and expenses system obviously was used by all the consultants at ThoughtWorks to log the hours and also log the expenses that they acquired over the course of the work that they were doing. Now the problem is that thought workers are iconoclasts. They love to make life interesting for people by taking strong and interesting technical directions. And although everyone in the company had been told that they should use Internet Explorer in order to file their expenses, some people were using Firefox and some people were using Opera. So what would happen is Jason, working basically on his own or with a very small team at ThoughtWorks, would write everything and hack on it and try and get that expenses system working in Internet Explorer, only to be told by people using Firefox that the expenses system didn't work. So he'd fire up Firefox and he'd sit there and he'd fix problems to do with that happen in Firefox, only to then be told by people using Internet Explorer that the expenses system didn't work. Another bug had come up. He'd fix it in both Internet Explorer and in Firefox, and users of Opera would then complain that the thing was broken. And he was a bit flummoxed about the best way of solving and fixing this particular problem. Now, the interesting thing is that the reason why this time and expenses system broke so readily is because it was essentially a JavaScript application. It's one of the first single-page JavaScript applications I ever came across, actually, although we didn't call it that at the time. And so he realized that if he could somehow write his tests using JavaScript and drive a browser, then he would be able to very quickly and simply verify that any changes he made worked in any browser that was available to him. And so this is what he did. And the testing framework he wrote ended up becoming the heart of Selenium. Selenium Core is what we call it now. Selenium Core is a JavaScript application that allows you to control a web browser. And it hooks into these commands that are added to the tables. So you create your tables, you execute it using the Selenium test runner, and away you go. You've got verification that the software you've written has continued to work. The only problem is that tables are incredibly difficult to edit and maintain, particularly if you're a software developer. If you're a software developer, you love code. You use a language such as Java, C#, Python, Ruby, JavaScript these days, anything really that comes to hand. You definitely do not program in HTML tables. And so there was a push to create a remote control mode for Selenium, Selenium RC. And what this does is it allows you to use a programming language of whatever you fancy to communicate with a server, the Selenium server, which in turn speaks the core protocol that's used to control the JavaScript application that is Selenium core. So you have this sort of multi-step process. And that was great. I mean, that's a wonderful thing. But the problem is that you're running deep inside the JavaScript sandbox. And the JavaScript sandbox is hard to break out of by definition, right? It's the thing that the browser uses to protect users from malicious websites. So in about 2007, January the 3rd, 2007, I pushed the first version of what is known as WebDriver live. WebDriver takes a different approach to browser automation, and that is to bind as tightly as possible to the underlying web browser. So for Firefox, that meant being written as a Firefox extension. For Internet Explorer, that meant hooking into the sort of COM controls that form Internet Explorer. If you're not familiar with IE and how it's structured, Microsoft have a technology called COM, and these are a series of interfaces that define behavior. And Internet Explorer is a collection of these COM objects bundled together and put in a skin. And that's the thing that you call a browser. But you can control the COM objects programmatically as well. And that's how the IE driver initially worked. Chrome and Safari came along later, as well as Opera. So we had WebDriver, and it binds tightly to the individual browsers. Now that's great because it means that you're not constrained by the JavaScript sandbox, which means that the more sophisticated testing that we need to do these days is possible. You know, drag and drop in Selenium Core and Selenium RC was incredibly difficult to implement. In WebDriver, it's remarkably simple. If we want to cross domains, if we want to go into iframes in separate domains, we don't need any clever hacks because we're part of the web browser and we can do all sorts of interesting things. Whereas JavaScript is forbidden from going cross domain, for example, by the sandbox. The downside is that with this great power becomes the difficulty and complexity of actually hooking into the browser. Each browser is written in a different language by a different company, and occasionally, quite often in fact, the source code isn't available. For example, there's no way to look at the source code of Internet Explorer unless you happen to be an engineer at Microsoft, and very few of us are, globally speaking. So what we were trying to do is figure out how to solve this problem. The other problem that we had with WebDriver is that if each browser spoke a different wire protocol, every language would need to have a different version of the wire protocol in order to support every browser. So if there are X browsers and Y languages, you'd have X times Y different implementations. And that would just be completely unmanageable. So what we did in WebDriver is we created what was known as the JSON wire protocol. And the JSON wire protocol is essentially sending JSON blobs representing the commands that we want to execute over HTTP to an endpoint. And that endpoint might be sitting inside a browser, as it is with the existing Firefox driver, or it could be a shim or a binary on your local machine, as it is with the existing Chrome driver. And that shim then communicates with the browser in a browser-dependent manner, having translated the command. So WebDriver came along, and it was great. Jason and I agreed to merge our two projects, and everything was going swimmingly. But the problem is that browsers didn't stop getting more complicated, and the web became more and more sophisticated, and additional features were added. And it was becoming increasingly difficult to keep up. It was at this point that Opera Software suggested that we take the WebDriver implementation that we had in Selenium and standardize it with the W3C, the World Wide Web Consortium. The World Wide Web Consortium are the people who maintain standards such as HTML, CSS, and XML. They're the sort of main standard setting body for the user-facing web. So with Opera's backing, we went to the W3C, we proposed WebDriver, and currently that working group is going forward as part of the Browser Tools and Testing team. and it has Microsoft, Google, Opera, Mozilla, BlackBerry, and a handful of other companies involved, as well as invited experts such as myself. So we released Selenium 2, going back now, Selenium 2, and Selenium 2 is the merging of the two projects, Selenium and WebDriver. And it ships with two sets of APIs, Selenium RC and Selenium WebDriver. On releasing Selenium 2, the advice that we started giving users was you should switch to the WebDriver APIs. And there were two reasons for that. The first reason was that the WebDriver APIs are more programmer friendly. They're more object-oriented. They're easier to discover and walk through with an IDE with auto-completion. And the other reason is that the tight binding with the browser means that the longevity of those APIs is far more guaranteed. Selenium Core, we knew, had a limited lifespan because it was JavaScript based and it was becoming increasingly hard to test things in JavaScript. So fast forward to a brief history of the future. Selenium 3. What is this going to be? Selenium 3 is where we remove Selenium Core, that sort of underlying JavaScript application that used to control the browser, and we just leave the WebDriver APIs. In addition, what we have is the beginnings of the W3C WebDriver compliant protocol being implemented as part of the client libraries offered by Selenium. If you speak with, if you try and use a W3C compliant WebDriver server, such as the Gecko driver that ships from Mozilla, then Selenium 3 will be able to communicate with it. Ultimately, we're going to end up with Selenium 4, which will be just the W3C WebDriver protocol. And at that point, will be completely standards-based, using internationally agreed standards. This can only be a good thing. Now, what are we going to do? I just said we're going to remove core, and that sounds a bit alarming, right? You've probably made a fairly significant investment in your tests and in your testing infrastructure. And although for the past 5 years or so we've been telling people that they should use the WebDriver APIs, there are still people using Selenium RC. Your existing investment in tests is an important asset to you and your company. What we definitely don't want to happen is when you switch to Selenium 3, for your existing tests, if you were using the older APIs that are deprecated and have been suggested against using for quite some time, if you're using those, we don't want you to throw away that investment. In addition, if you're using Selenium IDE and you've been exporting your tests, we want you to continue to be able to run those tests. So that's really important to us, and it's one of the key reasons why the release is taking a while. I'm going to be covering more later on how to maintain your existing investment in your Selenium RC tests. But the takeaway from this talk should be, if you haven't already done it, you should be moving to the WebDriver APIs, because these are the ones that are going to be supported going forward in the Selenium project and indeed by the standards bodies. There's a perfectly reasonable question that comes up, and the perfectly reasonable question is, when will Selenium 3 ultimately ship? I mean, we've been working on this thing for a while. In fact, in 2013 at Selenium Conf in India, I think it was, I stood on stage and confidently announced that we were going to ship Selenium 3 by Christmas. We singularly failed to ship by that Christmas, but I think I gave myself some wriggle room by not saying which Christmas we were going to ship by. The release sort of ground on for a while. It didn't really happen nothing very much happened for quite a long time until at Selenium conference this year, again in India, I stood on stage and confidently said that we were going to release Selenium 3 probably during the conference. Once again, this being open source, the deadline that we set ourselves whizzed by, and we failed to ship it. So when will Selenium 3 ship? It'll ship soon. I think that's the best answer I can give you. The reason why we're taking our time is that obviously a major version number bump is something we want to be very careful with. And so what we're doing is we've been releasing betas. We released betas 1 to 3 fairly recently. Beta 3 came out about a week or two ago. And we're currently working on beta 4. Beta 4 will probably be the final beta before we move to Selenium 3.0, the final release. Selenium 3.0 will obviously be followed by 3.1, 3.2, 3.3, and so on and so forth. It's going to be a lot of fun. So let's take a look at an example Selenium test and get a feel for what the new Selenium 3.0 will be like. So this is a fairly basic test. I hope you can all read this properly. But we're doing a Google search. This example is programmed in Java, and I'll just walk us through it. What we want to do is we want to use a Gecko driver. More on that later. And once we have Gecko driver, we fire up a new Marionette driver, which understands how to use Gecko. We create a new WebDriver instance, and then we create a wait, which is an explicit wait. We then go to www.google.com, and after loading that page, we get the current URL. Now, Google.com always redirects you to a secure version of the site, so we just verify that we have been redirected to a secure site, which is what that assert that current URL starts with https:// is. With Selenium RC, this would be a very difficult thing to test, because what we would need to do is inject effectively do a man-in-the-middle attack in order to be able to inject ourselves into the page under test. And that would be incredibly complicated and technically challenging. With the WebDriver approach, because we're part of the browser, it doesn't matter that we're using a site secured with SSL. We then find the element with the name Q, the search box, and we type in cheese and hit the return key. We then we find the link with Wikipedia in it, and we click on it, and then we wait until the title contains the word cheese. So here you can see that we're using the explicit waits just to allow us to do various bits and pieces, notably finding a link with a partial link text, and secondly waiting for the title to contain the word cheese. Now, the explicit waits are kind of interesting because they indicate to someone reading the test that we're expecting a page load or something to happen. So someone reading this test who's familiar with the WebDriver APIs will see that effectively when we type the word cheese, we're then expecting the page to refresh in some way and for our results to be present. And when we click on that link, we're realizing that it might take some time until the title until the page is loaded and the title contains cheese. If you're an existing WebDriver user, your upgrade path to 3.0 is going to be really easy. All you need to do is remove references to deprecated classes, because we tend to remove deprecated classes, and then you just drop in the Selenium 3.0 jar. If you're using Maven, you can just change the Selenium Java dependency to point to 3.0.0, or currently 3.0.0 beta 3, and that will be all you need to do in order to pick up the latest and greatest. The reason why we suggest removing references to deprecated classes is one of hygiene. The policy on the project is that when we mark a class as being deprecated, we mark it for a single release as being deprecated, and then we remove it in the second release. So it's always a good idea, just to sort of, as a matter of hygiene, if you see a reference to something being deprecated, avoid using that and update to the suggested replacements. So let's just step through updating this Selenium test to the new WebDriver 3.0. Okay, so we just dropped in the jar, and as you can see, Marionette driver is now marked as being deprecated, and everything else remains exactly the same. It's precisely what you would expect. Your code will continue to compile, and they will continue to run. What we do is the Marionette driver has been folded into the main Firefox driver, and so we just replace the Marionette driver with a call to Firefox, and then we're done. We have now upgraded the whole of our existing test to Selenium 3.0. Now, the nice thing with this is it allows you to experiment with the update. You can just change the jar that's in your system, possibly using a Maven coordinate, possibly by just updating the jars, and see whether or not Selenium 3.0 functions as you expect with your existing code base. If you try this with the betas, please file any bugs that you find. Your feedback is really valuable, and it's the thing that helps us make sure that a release is rock solid. That was pretty easy. Selenium Grid is the mechanism that we provide to allow you to take a test run and scale it horizontally across a number of different machines at the same time. So what you have is you have a grid hub which coordinates all the requests and a series of nodes that sit around that supply the browser instances. And when you say, can I have the machine, so you connect to the grid hub and then that reference back to one of the slave nodes. And this is pretty handy. If you're a grid user and you're not doing anything sophisticated, if you're just using this hub node configuration, then all you're going to need to do is drop in the 3.0 jar and you're basically done. The standalone server continues to behave as it's done for quite some time in the Selenium 2.0 cycle, which has been the standalone server can act as a grid hub, a grid node, or just as a standard Selenium server, so you can do remote control of a Selenium instance. So yeah, just drop in the jar, try it out, see what happens. Again, bugs would be fantastic. By the way, if you have any questions as we're going through, I can't hear what you're saying, but what you can do is just type into the chat window, and I'm sure that Dara will field those questions. I'll be answering them at the end of this talk. So yeah, upgrading for most grid users is remarkably simple and should be a fairly lightweight process. But RC users are going to have a bit of an experience. Again, we've been suggesting that developers move away from the Selenium RC APIs for quite some time. And although we're going to do our best to maintain that support your existing tests, we can't continue to support Selenium Core. So Selenium Core, if you remember, was the JavaScript engine that sat within the browser and was served by the Selenium server. And it was constrained by the JavaScript sandbox. With Selenium 3, we have removed Selenium Core, and at least in the Java world, we've replaced the implementation of the default Selenium with one backed by WebDriver. This WebDriver-backed Selenium has been available for years now as part of the Selenium 2.x lifecycle, so you should already be able to start testing with things like that. So what you need to do is run your tests using the WebDriver-backed Selenium. If you're a user of Python or Ruby or some of the other languages, you can also start a WebDriver instance, get the session ID, and then pass that to a Selenium instance started with star WebDriver instead of star Firefox or star Internet Explorer or star Google Chrome. So in order to upgrade for RC users, what you do is you switch from the default Selenium to a WebDriver-backed Selenium, and you run your tests. Now, because the implementation is very different, there are probably going to be a couple of hiccups. Things where we have noticed problems have been around the handling of alerts and prompts, particularly since what happens is with Selenium, you had to sort of know in advance that an alert was going to appear, and then say, on the next alert, do this, on the next prompt, here's the reply. And WebDriver is a more reactive API, so what happens is you wait until the alert appears, and then you switch to it, and then you handle it like that. What it means is that if we store a value on the web page, it's possible that we will lose the response that came back when a page refreshes. I will show you how to handle a case like that in just a moment. But there are probably going to be a handful of systemic errors that are caused by something like that. In the happy case, and I've seen this happen quite a lot, it just works. Maybe it works a bit more slowly, maybe it works a bit more quickly, but the path is relatively smooth. We've made a real effort to ensure bug-for-bug compatibility, in that if Selenium RC had a behavior when it was using Selenium Core, it should continue to have that behavior when you switch to the WebDriver-backed Selenium. But please note that the RC APIs are no longer supported. So if there are problems, what you can do is you can tell us about them, but you should be following the advice later on here, which is to migrate to the WebDriver APIs. Once your tests are running using the WebDriver-backed Selenium with the Selenium 2.x lifecycle, just drop in the Selenium 3 jar. The Selenium 3 jar, however, does not contain any of these Selenium support classes. So you also need to add a reference somehow to the legrc project. We called it legrc because, well, I love a really good pun. And although there's nothing like a good pun, it's good enough. Legacy, legacy, the old APIs. If you add that reference to the legacy API to jar, then the interface for Selenium will become available, default Selenium, and you can continue to migrate your tests. Once you have done that and you've updated your references, everything compiles again, you should think about how to migrate to the WebDriver APIs. If you want a really great example of that, Jason Labor's closing keynote at Selenium Conference in 2013 is a fantastic example of how that can be done. At the time, Google had literally thousands of tests that were using Selenium IDE, and over the course of 6 months, a year, they migrated every single one of them to WebDriver. It was initially suggested it was going to be an absolutely horrific effort, but it turned out not to be as bad as it could have been. Jason goes into a lot more depth than I will be able to, but he describes the process. One of the interesting things we found out is although people told us their tests were super valuable, they weren't always running them. And if a test isn't run, it clearly has no value, and it takes, there's no reason to migrate that test. You might as well just delete it. But again, go and have a look at that closing keynote by Jason Labor to see how Google managed their transition from Selenium IDE to the WebDriver APIs back in 2013, 3 years ago. So here's an example RC test written using the Selenium 2.53.1 release. As you can see here, we create a default Selenium. We go to, the server is running on localhost port 444, which is the standard default ones. We want to use Firefox, and we're going to go once again to google.com. So this test is exactly the same as the original WebDriver test, but using the Selenium APIs. Obviously, creating the Selenium class doesn't actually start it, so we call selenium.start. That causes the browser to load. We then navigate to slash. Obviously, that gets processed by the default Selenium to open google.com, and we get redirected to a site with HTTPS at the beginning, just as we did before. We then type name equals Q. This is a locator, and what this means is we're going to find an element whose name attribute is Q, and we're going to type cheese. One of the tricky things with Selenium IC is that it was really difficult to type things like return or enter. You needed to know the ASCII code, and it wasn't always guaranteed to work. Because WebDriver attempts to emulate user input, it was enough for us to use a new line character. I spent about 20 minutes trying to figure out how to get this to send an enter character to the browser, and failed miserably. So in the end, rather than sending a new line character, I click on this button G, and button G is a sort of magnifying glass that's on the right-hand side of the Google search. We then use the old wait class to wait until an element is present. We're looking for a link which has a regular expression of any number of characters followed by Wikipedia followed by any number of characters. Personally, I find this harder to read than partial link text, but it depends on what you're used to. Once we find it, we then have to find that link again, and then we click on it, and then finally we wait until the title says, hey look, it contains the word cheese. So this test is functionally identical to the WebDriver test that we saw earlier. So how do you do the migrating to the WebDriver APIs? Well, like I said, the very first thing you do is you replace the default Selenium, the first line of the test, with a WebDriver-backed Selenium. Here, because we wanted to use a Firefox driver, we create a new Firefox driver, and then we use a WebDriver-backed Selenium. Because our browser is already loaded, there's no need for us to call Selenium start, so we delete that line. The rest of the test is unchanged. Now, if you've got good encapsulation in your test frameworks and the way you've constructed these things, you should only need to make this change in a couple of places, and your test should continue to work. Particularly if you've been using patterns like page objects and so on and so forth. The next step is to start a migration to the WebDriver APIs. Now, it seems rather daunting to say that, but fortunately you can mix and match APIs while you're in the process of doing migration. You can see here how you can do this. The WebDriver-backed Selenium implements an interface called wraps driver. And you can see that after we go to google.com and we check that the page starts with HTTPS, we then grab the underlying driver, which is the Firefox driver from up above. We can then do whatever we want to do, but we can still use the Selenium instance because it's sitting on top of the same driver to do bits and pieces. And then right at the bottom, we've migrated to a more modern WebDriver wait in order to do the waiting for us. Now, if you're using a design pattern such as page objects, or if you have some form of encapsulation in your tests, what this means is that you can migrate your tests one object or one test at a time without needing to do everything in one fell swoop. And it's this ability to mix and match APIs that allowed Google to do their migration. I'm just going to take a drink. So this seems quite daunting, but it really isn't that bad. Now, because we've changed the way that the Selenium interfaces are implemented in the back end, the APIs remain the same, but the RC implementation has changed. You're also going to see some unsupported features, and here they are. Here are the key ones. The first thing that people used to do is, because of the way Selenium RC was implemented, it was quite often used as a proxy during tests as well. The new Selenium server does not support that sort of proxying capability. If you want to use a proxy, then I suggest taking a look at Browser Mod Proxy or a similar project in order to do what it is that you need to do. This is ultimately a good thing for the project, even if it it may not seem so to begin with. And the main reason is because we're really good at automating web browsers, and we're really bad at writing HTTP proxies. So by doing this, we allow people who are really good at writing HTTP proxies to take the strain and give you a better product. One of the reasons why people like to use the server as a proxy is to add custom request headers. Again, the new Selenium server is not an HTTP proxy, and so this feature we haven't been able to implement. You should be able to use something like Browser Mod Proxy in order to do the thing that you want to do. Another feature that Selenium RC used to offer is a capability called browser side logs. And a side log was information from the Selenium core implementation running within the browser. Obviously, there is no Selenium core, so there are now no longer any side logs. But each of the drivers that we have their own mechanism for doing logging. We are working with the W3C to standardize a logging API to allow programmatic access to those logs. But right now, each of the standalone drivers provided by the browser vendors is providing logging in its own format. You can still access all the information, but it's in more than one place. If you're using Selenium IDE, you probably are used to running it by going Java minus jar, Selenium server standalone minus HTML suite, and away you go. Again, that used to use Selenium core as the underlying engine in order to do things, and Selenium core has disappeared. So what we have is a new implementation with that runner, which you can download as a Selenium HTML runner jar. That's available from the Selenium HQ site right now. So if you go to seleniumhq.org, you can download it right now. And that will give you the new Selenium runner. You use that instead of Selenium server jar. So you type Java minus jar Selenium HTML runner.jar and then the parameter afterwards and run your tests. We've done our best to ensure that the outputs remain the same with the same output and the tests run in the same way. Obviously, underneath the covers, we are using WebDriver instead of Selenium core, so there may be some of the problems you see with the RC tests. If that's the case, then it's your opportunity to fix those up. Or file some bugs and give us a shout, because that table format is still supported. Missing IDE features in the new runner. Rollups are not currently implemented, but they are on the roadmap. We definitely want to implement them. JavaScript extensions, we handle them as best we can. Some of the ones that you sort of delve into the implementation of Selenium core will obviously no longer work. Some of the other ones, it might be slightly more tricky. We load them per page, so it's possible you might see some differences of behavior as well. As I mentioned with Selenium IDE, alert and prompt handling may be difficult. Finally, the sort of Selenium IDE exports tests in a format that was really close to the Selenium RC APIs and not the Selenium WebDriver APIs. If you want something a bit more modern, then consider switching to Selenium Builder. And I've given the URL there, seleniumbuilder.github.io/se-builder. If you just go to Selenium Builder GitHub.io, apparently there's nothing there. You get sort of no content page, but if you go to that full URL, it'll be present. Or have a think about writing code. Obviously, there are many use cases for IDE. And lots of those use cases end up with those table-based tests being written as normal code. So it's really useful IDE for capturing known problems or highlighting a quick bug, and that's great. And it's a bit more fragile. It's a bit more fragile if it's your main mechanism for running tests. But there we go. We'll do our best to maintain compatibility. Please file bugs with the betas if you come across them. And that moves us on to the W3C specification. Why do we need a W3C spec? The main reason is that browsers are fearsomely complex. If you delve into a modern web browser, they implement hundreds of different standards or tens of different standards to varying levels. JavaScript is slightly different between all of them, although it's far more standardized now thanks to ECMAScript. And we don't always have access to the source code. In addition, some of the features we want to do require us to very tightly introspect the state of the browser, and even for the open source browsers, that can be a challenge. The people who are best placed to properly control a web browser are the people that write the web browser. So the idea is that the browser vendors take responsibility for writing the WebDriver instances. The other nice thing that this effect this has is it decouples the open source Selenium project's releases from browser updates. For a long time, we used to have to release a new version of Selenium whenever there was a release of Firefox, because the Firefox driver contained binary components that were signed, and they only worked with a particular handful of Firefox instances. When a new instance came out, we had to upgrade everything, recompile them, and re-release the driver, and we couldn't do that independently of a full Selenium release. So our release schedule was tied very tightly to that of Firefox. This is no longer the case. So, like I say, how does this impact you? The vision is that browser vendors own the driver. Yes, this quite often means that you have another binary on your system. We'll come to that in a second. But that binary is released by the browser vendor, and therefore it tracks changes in the browser and decouples Selenium releases from the browser release schedules. If you're using Chrome and Edge or Internet Explorer, you're already using some of these standalone binaries. The Chrome driver and the Microsoft WebDriver are made by Google and Microsoft respectively, and control Chrome and Edge. Edge being the new web browser supplied by Microsoft as part of Windows 10. It's really rather good. You can try them out today, and if you're using Chrome or Edge, you are probably already using them. Selenium has been designed to detect that the servers are on the path, pick them up, and use them if at all possible. Coincidentally, with the release of Selenium 3, Mozilla have made some architectural changes to Firefox. Those architectural changes have allowed them to be more stable, use less RAM, and generally be a more efficient and snappier browser. It's only for the best. But the downside is that those changes require us to be able to sign the extensions that we create, and they've switched to a multi-process model. It would have taken a significant amount of energy for us to re-architect the Firefox driver to support the multi-process model, and Mozilla would not sign the resulting XPI because of the security risk it poses to users. It does a whole series of things that if a user accidentally installed WebDriver, they would not want. Therefore, the open source Firefox driver is no longer going to be maintained. And instead, you're going to be able to use the Gecko driver, which is written and maintained by Mozilla themselves. I've included the URL that you can use to download Gecko driver. If you're trying out Beta 3, then try the 0.10 release. If you're using Selenium 2, then try the 0.9 release of that. No matter what happens past Firefox 47, so Firefox 48 and above, you might changes that have happened within Firefox. This doesn't matter which version of Selenium you use, whether it's 2.x or 3.x. If for whatever reason you can't get the Gecko driver to work for you or it's not good, the best advice we can offer is to use the extended service release, the EuroSTAR release of Firefox, which is prior to version 48, and to continue using the original Firefox driver. The original Firefox driver XPI ships as part of the Selenium 3 betas, so you can try your update while holding the Firefox version stable. The Gecko driver has come on in leaps and bounds over the recent years, but there is one major problem with it, which is does not support the Advanced User Interactions APIs at the moment. The guys are working super hard to make sure that happens because they're aware that everyone wants to try and use them. If you find that the Gecko driver really does not do what you want it to do, please let the Mozilla guys know, and you might want to consider switching to something like the Chrome or the Edge driver in order to do your testing moving forward. With Safari 10, which is coming out very soon, Apple have supplied their own Safari driver. This is great news because it means that one of the most popular browsers in the world is now being driven by a driver written by the vendor. Once Safari 10 ships, the Selenium project will no longer maintain the open source Safari driver, just because it's an incredibly complicated extension and it doesn't function the way we really want it to. It's good, but it's not as good as the Safari driver that Apple will be shipping. So it's in everyone's best interest to switch over to that. As a user, this should be relatively seamless. Safari 10 puts the required driver in user bin, and we know it's going to be there, so we can just pick it up silently without you having to make any changes to your tests. Finally, before I finish, there are a couple of things that the Selenium team wished you knew and that we've done a really not quite perfect job telling you about in the past. So here's my chance just to tell you a couple of things. The first thing is how timeouts work. There are two kinds of timeouts. There are implicit timeouts, and these are implemented within the browser. So your request leaves the test, goes to the browser, and the browser does a couple of checks. And those timeouts are used when you're finding elements in particular. So you might set that to a 30-second timeout, and if an element isn't present on the page, the browser will wait up to 30 seconds before replying. The other kind of timeout, which is implemented using WebDriver wait or similar classes, is an explicit timeout. And they occur in what we call the local end, that is within your test. Now, what isn't clear sometimes is the interaction of these two. So explicit timeouts also allow you to wait for elements, but the way they're written is they're a bit more flexible, so you can wait in far more sophisticated conditions. The team suggests avoiding using implicit timeouts wherever possible, and that's, like I say, because of the interaction between the two. If you set the implicit timeout to 30 seconds and the explicit timeout to 5 seconds, the implicit timeout will take precedence. So what happens is the test goes, I need to wait for up to 5 seconds, sends a request to the browser goes, okay, I'm going to find this thing, I'm going to wait for my 30 seconds, the implicit timeout. Once that has timed out, it goes, I couldn't find anything, returns the wait in your test, and the wait in your test then goes, oh, more than 5 seconds has elapsed, and then the exception is thrown. Pardon me. In the example I gave, the test would have waited an additional 25 seconds. So if at all possible, crank down the implicit timeout as low as possible and favor using explicit timeouts, particularly when things like page loading, re-rendering complex UIs using JavaScript are taking effect. We added implicit timeouts because we're fully aware that sometimes it's not clear when these changes will occur, particularly on single-page applications. So it's not like do not use them, but the suggestion is very much avoid using them as much as humanly possible. And if you can, set the timeout to be quite low, 1 or 2 seconds at most. Favor using explicit timeouts. The other thing that we wish we told you about was using XPath. Years and years ago, XPath had to be implemented in JavaScript. JavaScript engines were incredibly slow. What we do now is we depend on the underlying browser's XPath implementation. All major browsers, except for Internet Explorer and Edge, ship with their own XPath implementation. Where possible, we delegate down to that. That does mean that some sophisticated XPath expressions may behave differently on different browsers because they rely on different parts of the XPath specification which are implemented in an uneven way. So tip number 1, keep your XPath simple. Tip number 1, keep your XPath simple, also plays into maintaining the readability of your tests. Occasionally people write to the Selenium user lists or come onto the IRC channel asking for help, and they have an XPath expression which is almost impossible for a human being to read. Those XPaths destroy the readability of your tests, and worse, they're incredibly fragile. Testers seem to be the only people who use XPath on a regular basis, and that causes all manner of chaos. The suggestion is, if at all possible, to use CSS selectors instead. CSS selectors are used by your design teams, and therefore you're not going to be the only people using these things. They're going to be more stable, they're going to be less fragile, and the nice advantage is they tend to be slightly easier to read. On the plus side, advances in JavaScript engines and the fact that we can delegate down to native XPath implementations means that the prohibition against using XPath because of speed is probably no longer true. Obviously, you don't want those complex expressions because they're hard to read, but you should be able to use XPath if you really need to. Microsoft ship a JavaScript implementation of an XPath engine as part of the Edge driver, the Microsoft WebDriver, and that XPath engine is very fast. It was optimized while I was at Google for use there. It's incredibly fast, and better still, the JavaScript engine in the Microsoft browsers has come forward in leaps and bounds. It used to be one of the slowest ones on the market. It's now incredibly rapid. So yes, that's using XPath, updated advice. So questions will be happening in just a bit, but before then, I think Dara has a couple of questions a couple of comments he'd like to make.
Thank you very much, Simon.
Thank you very much, Simon.
I'm picking up there on your microphone. Just want to say thank you again for everyone attending today's webinar. I'm just going to put you on mute there for a second. I'm picking up on your audio. Okay, yes, I'm back again. Sorry about that, guys. I was just hearing double audio. If you want some more Selenium content, we have an ebook that we released there recently with Dave Hefner called the Selenium Guidebook. It's a great read, very popular. It's over on Test Huddle. We also have a number of other webinars taking place this week. So tomorrow we have a webinar with James Bach and John Bach, and they'll be looking at the concept of thinking through your role. We also have 2 webinars taking place this Friday. The first of them is with Hybe Schutz, who will be talking to you about practical test strategy using heuristics. And then to wrap up the series, we have a webinar with Penny Resnick, who will be talking to you about testing cloud native applications. Now next week is the deadline for our early bird discount of 10%. So if you want to buy your tickets, now is the cheapest time to do so. And also, we have a group discount where if you buy 4 tickets, you get 1 ticket free. And I just want to point out as well that the group discount is not just for the early bird. This is available all year round. And I've shared a couple of different pieces of information with you there. So there's a number of different links. So I'll just share them with you there in your chat box to the various sources of content. So now let's have a look at some of your questions that have come through here. And if you haven't already typed your questions, you can please do so now. The first question I'm looking at here, Simon, is asking, could you explain the differences between Marionette driver and Gecko driver, please?
There we go. Now I can speak. So the difference between Marionette driver and Firefox driver. In Selenium 2, the main difference is that the Marionette driver is optimized for speaking with the Gecko driver that has been released by Mozilla, and the Firefox driver relies on communicating with the Firefox driver that is being implemented by the Selenium project. With Selenium 3, because we know that we're no longer going to be able to use the Firefox driver, and because having to figure out which version you were using to chat to the server was incredibly complicated, we've just removed that distinction. And now the Firefox driver will detect automatically whether it needs to talk to the Gecko driver or use the open source Firefox driver extension. And it will do that dynamically and for you. So we've simplified the use case. Because we've done that, there's now no need for a separate Marionette driver, and so we've deprecated the Marionette driver. But certainly as a bridge to get you onto Selenium 3, if you want to try out the Gecko driver, what you can do is you can just switch Firefox driver for Marionette driver, try that with 2.x, and when you slip onto Selenium 3, you can then switch back to using Firefox driver. That's basically the only difference.
Are there any changes related to the support for mobile apps automation with Selenium 3.0?
So the mobile app implementations, I assume the question is asking about things like Appium, iOS driver, the WebDriver agent released by Facebook, things like that. Those use the same wire protocol as used by Selenium 2. The JSON wire protocol, and they have not yet migrated to use the W3C protocol. Now, one of the main reasons for not switching to the W3C protocol is that we haven't actually finished writing the spec, and so switching to try and use that protocol right now is a somewhat risky proposition for the makers of tools such as Appium. We have made no changes to the wire protocol. And so the JSON wire protocol is used by 2.x, and so you will continue to be able to use the Selenium clients to control those remote things. We have made no changes to adding new endpoints, new methods, new commands, or anything like that. Part of the W3C level 2 specification, which is going to kick off once we finally ship Selenium level 1, WebDriver level 1 even. That level 2 stuff may include some mobile pieces, and at that point, as part of the Selenium 4 work, we'll be adding additional endpoints to track the W3C specifications. I hope that makes sense. If not, feel free to hop onto the WebDriver or Selenium user mailing lists and ask the question there, and we will try and follow up and be a bit more coherent. But I hope that makes sense. Next question, please.
The next question here is asking, are there any new functions that were not offered in all previous versions?
New functionality. The major thing to take away from this talk is a reason why we're jumping from Selenium 2 to Selenium 3 is that we are removing support for the remote control, the RC APIs, and we have removed Selenium core completely. Because these are fairly radical changes, it seems fair to want the major version number. What we haven't done is focus on new capabilities, new functionality, anything like that. Having said that, the forthcoming changes that we're making to Advanced User Interactions APIs as part of the WebDriver W3C spec work will probably allow you to do some really nice control of the web browser using sort of things from pointer event. So you can simulate touch input, pen input, as well as mouse and keyboard input, which I think is going to be a nice little addition. The WebDriver APIs are fairly stable. I think they cover most of the common use cases, except for those cases where we are doing things like the Advanced User Interactions APIs. So there will be some enhancements coming, but we expect the WebDriver APIs and interfaces to remain stable from 2 to 3 to 4.0. Yeah, so the main reason for bumping the version number, we've removed things, we've made it slimmer and easier to maintain, not because we've added a whole bunch of additional capability. Next question, please.
The next question here asks, actually states that a lot of effort has been put in here to keep support for RC. Do you have any stats on how many people are actually still using it? No, we don't. Selenium never phones home to tell us which API you're using, and it's quite hard to track. My gut feel is that RC support is actually pretty minimal. RC usage is pretty minimal these days. Salesforce, I think, were big users of it, but they've been doing migration to the WebDriver APIs, and I think there are fewer RC users than there used to be. But what we don't want to do is make people rewrite all of their existing tests with a huge effort. That seems like a waste of time. If it ain't broke, don't fix it. So we'd like people to be able to do a managed migration. Slightly more concerning for me is I think there are a lot of people using Selenium IDE, because Selenium IDE doesn't require you to be able to understand how to program, and it's very easy just to go click, 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 and drive it. So if you're a tester who isn't familiar with programming, it's a fantastic tool to allow you to capture particular use cases and demonstrate whether or not something is working. The new runner that we have is a new runner. I'm sure there are going to be some rough edges with that, and I'd really appreciate some feedback from early users, particularly the betas, just letting us know what they're using and what problems they're running into. Because although we've done our best to make sure that your IDE tests that you've exported will continue to run, we can't guarantee it. The next question.
So, yeah.
Oh, sorry. The next question I have here asks, how does retrying locators for the page object model work with explicit timeouts? Are they just implicit timeouts or something different?
Okay, so what happens is the WebDriver waits class, you give it a timeout. As you saw in the sample Selenium WebDriver test at the beginning of the talk, what you do is you pass in the driver to use and the timeout in seconds. So I think I used 30 seconds. What happens is once every set number of amount of time, I think it's 250 milliseconds, the condition that you pass in will be evaluated. If that condition returns a non-null value or not false, so if it returns true, then we assume that the condition has passed and we pass that forward to the result back to the users so they can do stuff. All of that checking, all of that looping happens within your test on the local end, on your local machine. There is no implicit timeout sent to the browser. An implicit timeout is implemented entirely within the browser. So once we send off the request, we never get a chance to interrupt it, stop it, or anything like that, which is why they sometimes take an incredibly long time. Also, because they're implemented in the browser, there's no way of handling sophisticated checks. For example, there's no way in that example test that I gave where we waited for the title to contain the word cheese, there's no way to do that implicitly. You have to do that explicitly. Because the implicit weights really only apply to element finding. So the implicit weights are not very sophisticated. They unnecessarily slow your tests in the case where, hey, look, something has gone horribly wrong. And they interact very poorly with explicit weights. So the best bet is to make use of explicit weights wherever possible, and set the implicit weight as low as possible, ideally to 0. I hope that helped.
We've gone way over time, but there's so many questions here. We might take 3 more questions and we'll leave it at that. The first question I have here is, did you try Selenium 3.0 with Cucumber?
No, but it should work just fine. The reason for that is the WebDriver APIs have remained unchanged, and therefore, and Cucumber uses the WebDriver APIs, so where possible. So I think that'll be just fine. The same goes for the test tool that ships with Angular and things like that. We've kept the APIs as stable as possible when we go from 2 to 3, because what we want you to be able to do is just have a smaller download and something that's more effective rather than a radical change of APIs for the things that we currently support. Next question.
Can we expect Selenium WebDriver for desktop applications?
Desktop applications. Good question. Years and years ago, Jason Huggins and myself discussed the use of accessibility APIs in order to allow a sort of unified testing capability from all the way within the browser through to the desktop. The Selenium project probably won't do that, and the W3C probably won't do that as well because it's interested in the web. Having said that, there are already a couple of products that are out there. Off the top of my head, there used to be a tool called White, which was written by someone from ThoughtWorks India, which was great. It used the accessibility APIs offered by .NET 3 and above in order to allow you to do desktop testing. eBay also released a tool called Twin, I think it was, that allowed you to use the WebDriver APIs for testing desktop applications. So although the Selenium project probably won't implement any desktop testing APIs, APIs based on them or using the wire protocol are available if you're interested in that kind of thing, but they're separate projects that are run independently. And the final question.
And the final question here, the interesting one here to wrap up with, where would you see Selenium in 5 years?
Good question. So if we haven't finished the level 1 specification in 5 years' time, I'll be weeping. So Selenium WebDriver, the WebDriver spec should be finished relatively soon as far as these things go. So in 5 years' time, I would expect that to be available not only in the desktop browsers but also the mobile browsers. So Boot2Gecko supported the Firefox driver, the Gecko driver for a long time. I would hope that iOS Safari will also eventually be controllable through the WebDriver APIs. Ages ago, James Whitaker asked me a very similar question about when would I consider the Selenium project to be a success, and it was like, well, when you no longer really notice that it's there, like when you just expect it to be there and it works the way you expect it to be. And in 5 years' time, I think we're going to be there. I think once we ship Selenium 4, or maybe even sooner, the focus of the project is going to change from being very technical about like how do we implement new drivers, how do we add capabilities, how do we change the APIs, to being something that tracks the W3C standards and perhaps feeds into them by user-requested features. But we should be switching our focus onto better documentation, better tooling around WebDriver, and better usage. Now, one of the other things that comes from the W3C spec is that ubiquity means that there'll be other tools based on top of it. So Hewlett-Packard, for example, were at the recent Selenium conference in India, and they were talking about sort of some of the tooling they're building on top of the WebDriver APIs. And I expect that sort of ability to control a browser programmatically in a very clearly defined way is going to be incredibly useful. So I think in 5 years' time, we'll see the Selenium project being sort of the lowest tier of more sophisticated, more user-focused testing applications. But we shall see. I mean, it's only 5 years away, right? 2021. Don't have to hang on for too long. And I think that's what I'm going to say to that. Before we finish, can I just say thank you very much for your time and attention. I really appreciate all of you having been there, and thank you to Dara and the EuroSTAR conference people for organising this. So thank you.
And thank you, Simon, for taking time out and bringing us all up to speed with the Selenium 3.0. There's been lots of really positive feedback. Everyone seems to be very happy. Apologies for not being able to get through all of your questions. We might be here till next week if we did, but we appreciate you coming along, asking all your questions, and we hope to see you at the rest of the webinars we have this week. One question that did pop up quite a bit was, is this webinar being recorded? And the answer is yes, we record all of our webinars, so you can check out the recording of this webinar over on the Test Huddle website very shortly. So that's it from us today. Thank you all very much and take care.